More in 6th grade. Hopefully you got the quiz done on the back side. Great answers. Got the top done. And you attempted the subtraction thing. We'll see how you did with the subtraction missing number problems. And then remember, when we go back to actually working the lesson and doing these problems, guys, it's back onto the back side of your quiz. You're writing the work down here from all those examples so that I can see that your brain is understanding what it is. All right, let's work up the challenge problem. That looks like this. Now, we've had this one other time, guys, where we're missing things in subtraction. This one is a step higher because we're into lesson 15 here. Okay, so I'm doing missing in subtraction. Missing the first one in subtraction, I add. So I have 7 plus 5 is 12. So I write down the 2, and remember I carried that 1. So if I carried that 1, where did that 1 come from? That 1 came from the 7. I crossed it out, made it a 6. That gave me the 12, so I could do the subtraction. So now my new subtraction for the next one is 6 minus 6 is 0. Okay? Now we're going backwards this way. And we're doing this one. I'm missing the second in subtraction. I still subtract. 3 minus what is 9? Well, it's not 3, guys. It needs to be 13. So I crossed out this number, brought a 1, and did 13 minus 9 is 4. Okay, now we got to go back and figure out what this number is. Now, there's 2 ways to do that. One is keeping our pattern going. The other way, guys, is you have 2 numbers right here. So you could just add these 2 numbers together to see if you got the right answer. I'm going to do both of them with you. Missing the first in subtraction, I add. 5 plus 2 is 7, but remember, I crossed it out and brought this 1 over. So the 7 really becomes an 8. Because it wasn't 8, I crossed it out, made it a 7, made that a 13. So I think the correct number is 8,362 minus 2,465. And I think my answer is 5,907. And I'm just going to do the subtraction to see if I'm right. Sorry, look what I did. I wrote the 6 and it was supposed to be the 7 there for my answer. So cross out the 7, make it a 6. 12 minus 5 is 7. 6 minus 6 is 0. Can't do. 8 becomes 7. 13 minus 4 is 9. 7 minus 2 is 5. 5,907, 5,907. So 8,372 minus 2,465 gives me 5,907. So you can see this was a few more steps and a little bit more complicated to be able to get that one. Okay, we got the power up done, guys. Now you're on the back side of that power up quiz, ready to do the work that comes with lesson 15. Hopefully you have your yellow folder there. We got one little blank to fill in as we continue to work these math folders. Last week we had a lot of word problems. So we started, lessons 1 and 2, missing things in addition, subtraction, multiplication, division. Now we switch that to real life word problems. Today we're going to go back into fractions. And now we're going to learn the official lesson of reducing fractions. So from now on, guys, everything needs to be reduced. So we actually have 2 lessons that are opposites of each other. The first one is what we call equivalent fractions. Can I unreduce them and get them bigger so that they're preparing you for adding and subtracting fractions with uncommon denominators, and then can we reduce everything with our answers so they look right? Let's get started. Different fractions that name the same number are called equivalent fractions. Okay, so you got your blank filled in already, guys. Different fractions that name the same amount. Equal, you can see the root word of equivalent. Here we show 4 equivalent fractions. 1/2 is the same as 2/4, is the same as 3/6, is the same as 4/8. As you can see from the model, equivalent fractions have the same value. Recall that this is the identity property of multiplication, because what we're doing is we're taking a fraction and multiplying it by 1 so that we can get a different answer that's equal. We can form equivalent fractions by multiplying a fraction by fractions that is equal to 1. Here we multiply 1/2 by 2/2, 3/3, 4/4 to form equivalent fractions to 1/2. Okay, guys, we usually speak wrong when we do this. For example, let's do number 1. It says find the equivalent fraction for 2/3 that has a denominator of 12. So I usually go, hey, what did I multiply 3 by to get 12? And you say 4. Okay, so if I multiply by 4 on the bottom, I multiply by 4 on the top, 2 times 4 is 8, and I have an equivalent fraction. And so what did I say? I said, what did you multiply? And you said, we multiplied by 4. We didn't multiply by 4, guys. We multiplied by 4 over 4, which equals 1. That's the identity property. So we've been doing those things where we've been working with the cumulative property and the associative property and the steps. When we start to bring in the fraction now, they'll start using the inverse property, multiplying by the reciprocal, and the identity property as we work those in the future. So I don't mind if you say, I multiplied by 4. Just understand you're really multiplying by 4 over 4, which equals 1. That's why we can do that. Example 2. It says, find a fraction equivalent to 1/3 that has a denominator of 6. Next, find a fraction equivalent to 1/2, then add them. So they said, hey, here's step 1. Can you find 1? Now let's do it again, and can you find 2 of them and then put them together? So I have 1/3. 3 times what gives me 6? Times 2. 1 times 2 is 2. Some of you are going to be able to do that quickly in your head. Some of you might want to write the 2 over 2 box if that helps you. 2 times what gave me 6? 3. 1 times 3 is 3. Then they asked me to add those together. 2 plus 3 is 5. 6 stays the same. And they just gave you a lesson on adding fractions with uncommon denominators without telling you that. They're showing you the steps. We're eventually going to get to that pretty shortly in a lesson coming up. Okay, second part of our lesson, how do we reduce fractions? An inch ruler provides another example of equivalent fractions. The segment in the inch ruler in the figure below is 1/2 inch long. By counting the tick marks of the ruler, we can see that there are several equivalent names for half, like 2/4, 4/8, 8/16. We say that the fractions 2/4, 4/8, and 8/16 each reduce to 1/2. We can reduce some fractions by dividing the fraction to reduce by a fraction that's equal to 1. So I take 4/8, I divide it by 4 over 4, and I get 1/2. Okay? The numbers we use when we write a fraction are called the terms of the fraction. To reduce a fraction, we divide both terms of the fraction by a factor that goes into both of them. By dividing each term of 4/8 by 4 instead of by 2 results in a fraction with lower terms. Since the terms of 1/2 are lower than the terms of 2/4, it is customary to reduce fractions to the what we call lowest terms. As we see in the next example, fractions can be reduced to lowest terms in one step by dividing the terms of the fraction by the greatest common factor of the terms. Okay, so guys, here's what they're saying is this. I have 8/24 and they say please reduce it into lowest terms. To do it in one step, I have to be able to say what number goes into both of these. It's 6 over 6. So I divide by 6 on the top, I get 3. I divide by 6 on the bottom, I get 4. I'm in the lowest terms. Now, that one you might have saw and say, hey, sure enough, I know 6 goes into both of those and I got it done. But reality is we're going to start to get fractions where you might not instantly say it's 6. For instance, I looked at this and said they're both even. I'm going to divide by 2. So I'm going to do this one again how my brain worked. I had 18/24. I saw that they're both even, so I just said 18 divided by 2 is 9, and 24 divided by 2 is 12. Then I said, hey, is this the lowest terms? No, 3 goes into both of those. So then I took my answer and divided again by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. Notice we got to the same answer. If you saw the 6, you did it in one step. If you didn't see the 6, you did it in 2 steps. And you're like, well, I always want to do it by the 6. I can do it in one step. That might be true, guys, but it might take you longer to think of the 6 to divide by instead of just going, it's even, go. And so as we start to get bigger and bigger fractions, in other words, today, guys, they're going to start out fractions like this, where you might be able to see it in one step. Eventually, we're going to get to really big fractions, like 125 over 150, and you're like, whoa, big fraction. I got to think what to divide that by, kind of stuff. Okay, just find one and start to go. You might have to do it twice. So just get in the habit of always asking yourself, is this in lowest terms or can I divide again? Okay, example 4, you're going to see a progression. Takes it one step farther. Here I reduced a fraction. Here I have to reduce a mixed number. Don't forget your whole number. What do? I look at 8/12 and I say divide by 4 over 4. 8 divided by 4 is 2. 12 divided by 4 is 3. Don't forget your whole number. My answer is 3 2/3. Did it in one step. If you did it by 2, you'd have had to divide by 2 twice. Number 5 says please reduce 12/9. So now they said fraction, mixed number, Now improper. So step 1, I have to do top in, bottom out, divide 1, 9, subtract 3, 1 and 3/9. Then I say, is that in lowest terms? No, gotta divide by 3, which equals 1 and 1/3. 3 divided by 3 is 1, 9 divided by 3 is 3. If it helps you guys, write that out so you see that. But from now on, you can't give an answer of 1 and 3/9. That's wrong in our math class now. You have to reduce it to 1 and 1/3. Okay, example number 6 says, sweet, now you're going to do math before you have to reduce. So guys, we did math one other time, but it didn't take any reducing. Here, I subtract. 7 minus 1 is 6. 9 stay the same. I have 6/9 when I'm done with subtraction. I always ask myself, can I reduce? The answer is yes. Divide by 3. 3 divided by 3 is 2. 9 divided by 3 is 3. And my answer is 2/3. So you're starting to understand how important that divisibility lesson was. Back a few lessons ago, I think it was like lesson 7, 6 or 7, where we were learning all those divisibility. What does 2, 3, 4 go into it? So important, guys, so that we can do these problems a little bit faster. Example number 7 says, can you write 70% as a fraction? Okay, well, remember, what does percent mean? Percent means out of 100. So I write 70 over 100. Now I need to reduce that. Some of you might do the shortcut. Hey, there's a 0 on top, there's a 0 on the bottom. I just chop the 0 off of both. Why am I able to do that? I'm literally dividing by 1, written as 10 over 10. So 70 divided by 10 is 7, 100 divided by 10 is 10, and I have it reduced to 7/10. So reviewing of percents to fractions for us. And last but not least, turning the page, you have example 8 with probability that we did a few lessons ago. With one spin, what is the probability that the spinner will stop on a 4? Well, first I count how many are there. 1, 2, 3, 4, 5, 6, 7. There's a total of 8 pieces. Then I count how many of them are the number 4. And you can see that there's 2 of them. So my probability is 2/8. That doesn't work anymore. I have to divide by 2 over 2 to get reduced to 1/4. Okay? So reducing fractions, guys, is going to become automatic, but it's really good practice. Speaking of really good practice, you have all kinds of letters you can choose from to get that practice. You also have that IXL. If you struggle with reducing fractions, your math book expects you to be really good at it. So get on IXL and practice doing reducing fractions so that you can be able to do those things quickly. All right, I'll be ready for you to start working lesson 15 problems. As I switch over to the iPad now, remember, all work goes in the big boxes, all answers goes down the side. If you want extra credit, you do them all. I'll see you on the iPad. All right, 6th grade, here we get going on math lesson 15 answer set. You can see the first one we're doing is number 3. It reads like this. If 40% of all the citizens voted no on the ballot, what fraction of all the citizens voted no? We know percent means out of 100, so I write 40 over 100. I cross out the zeros. I'm left with 4/10. I divide by 2 over 2 because it goes into both the top and the bottom, and I get 2/5. Number 4. The farmer harvested 9,000 bushels of grain from 60 acres. The crop produced an average of how many for each acre? So that's an equal groups problem. It looks like this. I have 60 acres, each producing, I don't know how many bushels, would give me a total of the 9,000. Missing a multiplication, I solve it through division. I want to make the division easier by chopping a 0. If both the divisor and the dividend have a 0, you can chop them off. So 6 goes into 9 once. 6, subtract 3, bring down 30. 5 is a 30. 0, bring down the last 0, goes in there 0 times. So my answer is 150 bushels. Number 7, list the single-digit divisors of 2,100. All right, 1 goes into it because 1 goes into everything. 2 goes into it because the last digit is even. 3 goes into it because 2 plus 1 is 3. 4 goes into it because 4 goes into the last 2 digits. If it's zeros, it works. 5 goes into it because it ends in 0. 6 goes into it because of this 2 and this 3. 7 goes into it because I know the division. If I divide that by 7, that goes in there 3 times, 0, 0. 8, I have to check the last 3 numbers. So I look at 100, I divide it by 8, goes in there once, brings down a 20. 8 does not go into there evenly. I have a remainder, so there's no 8. There's also no 9 because when I add 2 plus 1, I only get 3. It has to add up to something that's divisible by 9. So the first 7 numbers, guys, are divisors of it. Number 9, find 3 equivalent fractions of 2/3 by multiplying by these numbers. So I have 2/3 times 3/3. Multiply the tops, 6. Multiply the bottom, 9. Next, I take 2/3 and I multiply it by, this time, 5/5. Multiply the tops, 10. Multiply the bottoms, 15. And multiply 2/3 times 6/6. Multiply the tops, 12, bottoms, 18. Okay, 6, look those in and say, start to memorize this first one and the second one. I instantly see that. I know it reduces down to this 2/3. Second part says what property? Guys, this numbers always equal 1. Multiplying by 1 is the identity property. Number 10, for each fraction, find an equivalent fraction with a denominator of 20. So that looks like this. 3/5 times, I don't know, equals something with a 20. How did I get from 5 to 20? It's a 4. Did it on the top, bottom, do it on the top. 3 times 4 is 12. Do it again. 1/2 times something that gives me 20. That would make the something 10. Bottom, top, multiply 10. 3/4 times, I don't know, equals something with a 20. That something on the bottom is 5, so you do it on the top and you get 15. So your 3 equivalent fractions are done over there on the side. Number 12, convert each fraction to either a whole number or a mixed number. So this is top in, bottom out. Goes in there 3 times, 9, subtract 2, 3 2/3. B, 12 divided by 3 is 4. And 3 into 13 is 4. That's 12, that's 1. 4 1/3. Flipping my answer key over, turning my page. Number 16, missing the first in subtraction, I add. I have $5 plus 5 cents. So that's just making sure you tell the difference between the signs. That's $5.05. Number 18, write each percent as a reduced fraction. So we remember, percents always mean out of 100. Chop a 0. They're both even, so I divide by 2. I get 4/5. Memorize it. The last one is 35 over 100. I'm going to divide by 5 because they end in 5 and 0. 35 divided by 5 is 7. 100 divided by 5 is 20. I look and say, can I reduce that? No. 7/20. C, sketch and shade a circle to show your answer to A. So I'm going to circle. I make the upside down peace sign. Extend my legs. Arms up, call what you want. 1, 2, 3, 4. And I just shaded 4/5 of it. Number 20. 20 says, justify your steps. They gave you 3/4 times 5/6 times 4/3. Then they switched the order on you. 3/4 times 4/3 times 5/6. Changing the order. Cumulative. Then they grouped them. Associative. Then they said this equals 1. A number times its reciprocal equals 1. Anytime it equals 1 is the inverse. 1 times 5/6 is 5/6. Multiply by 1, that's the identity. So guys, normally we only give these two in the steps up to this point. Now we're going to start to add all these when we have more fraction work. So make sure you memorize inverse and identity and how they work with it. 22. I have 3 5/8, and I'm subtracting 1 3/8 from it. 5 minus 3 is 2, 8 stays the same, 3 minus 1 is 2, and I need to reduce. Divide them both by 2. Gives me 2 1/4. So you're reducing the fractions now that we're done. 24, this time I'm adding 3/4 plus 3/4 equals 6/4. I have to simplify it by dividing. 4 goes into 6 once with a 2 left over, and 1 2/4 reduces to 1 1/2. 26, subtracting this time, 11/12 minus 1/12. I subtract the tops, 10, subtract the bottoms, stay the same, and then I reduce that by dividing both of them by 2. That gives me 5 and 6. 27, I have 5 6 times 2/3. They haven't taught you to cancel yet, guys, but I love to be able to see canceling. If I can divide the same numbers on the top as the bottom, then I do it. So 2 divided by 2 is 1. 6 divided by 2 is 3. Then I multiply the tops. 5 times 1 is 5, and 3 times 3 is 9. Okay, that is... Sorry. That's canceling, guys. It's literally dividing and then multiplying instead of multiplying and then dividing. Reducing is multiplying and then dividing. So we're trying to make the numbers smaller with that. It might be a shortcut. We'll get a lesson on it later on. 29, find a fraction that's equal to 1/3 that has a denominator of 6. 1/3 times gives me a 6. That is 2 on the bottom, so I need 2 on the top. Add that fraction to 1/6. Gives me 3/6, and then reduce it. So I divide both sides by 3 and get 1/2. And last, number 30. Write 2 2/3 as an improper. Multiply and add. 6, 7, 8. Multiply the improper by 1/4. Okay, so here comes the canceling. Divide by 4 on the bottom gives me 1. Divide by 4 on the top gives me 2. 2 times 1 is 2. 3 times 1 is 3. And if I do my canceling right, guys, I never have to reduce. Awesome.